Okay, so here is my virtual machine for that's is simulating the drone. So I'm going to start the simulator. We can simulate all kinds of different drones. For this demonstration, I'm going to use a fixed-wing drone, like an airplane, because in the future ones, I'm going to use a quadricopter. So we're just going to see here. I'm copying over this command that I've saved. It's going to load a default drone profile. With this simulator, we can use different kinds of drones, so we can set the parameters for the different drones. So if we had an actual physical drone that we're trying to model, we could set the simulator to respond to those same parameters. And you see here this provides simulation of the ground control station. So I'm going to go ahead and start the engines on the drone with the arm throttles command. Whoops, I forgot to put the proper mode in. The simulator uses the kinematics from JSBSim flight simulator to provide the actual modeling of the performance of the drone in response to environmental conditions, pitch, yaw, roll, things like that. For the ground control station, we're using MAVLink, which you can see here is primarily a command-based editor, but we also have input through the map. Okay, so we started up. The drone's going to follow this pre-planned track that I've laid out for it. So it takes off. It's going to get to an altitude of 100 feet, which you can see the altitude climbing right now. And then it's going to follow this this kind of box pattern around the airport. This is the auto mode of flight, where it's following a pre-established waypoints. We could use the simulator to input environmentals such as wind, speed and direction of different types, various other components, so we can see how that would affect the performance of the drone. We can also simulate faults to the drone, loss of communication with the ground control station, loss of GPS, loss of primary power if it had a secondary power module, those kind of things we can all input into the simulator through the command line. It's all on the same machine right now. The ground control station is also acting as the same machine running the drone simulation the operating system software and the flight simulator software. But we could configure that differently. But even right now, with it all on the same machine, the commands are being simulated using UDP over IP protocol, which is something I've been able to get very successfully to work with this simulation software. In theory, we should be able to use TCP over IP. But I have not yet been able to really get that to work. But the UDP works fine in all modes. So I'm going to go ahead here, and you can see I'm putting it in a loiter command. So that'll instead of being in the automatic on the racetrack, it's going to loiter around its current position once I press enter there. All right, so you can see now the drone is just going to follow a holding circle around the last position it was, just loitering in the area at the same altitude. So again, that simulates a command from the ground control station to the drone while in flight. So that would have been going over the whatever wireless connection is between the drone and the ground control station at that time via like a radio transmission or a Wi-Fi signal. So now I'm going to input a waypoint and an altitude to fly to at that waypoint. And I'm going to go ahead and put it in a guided mode, take it out of that loiter mode. So now it's following commands from the user. So this is kind of fly-by-wire type stuff, but it is using the GPS signal to tell it where to go when it's gotten there. Of course, the GPS signal is simulated in the simulator. It's not an actual GPS receiver. And And you can see once it gets to a guided waypoint, it just automatically starts to loiter around that waypoint until you give it another command. Alright, putting it back in the automatic mode of operation has it travel to the next waypoint where it last left off. So we were at waypoint 2, headed to waypoint 3, so now the drone is headed back to waypoint 3, and it'll resume that racetrack pattern around the 4 waypoints. And you can see in the console that stats such as the voltage of the battery and the percent battery power remaining are maintained and updated as the drone's in flight. We can change the size of that battery and its lifetime and the power consumption of the drone again when we change those drone parameters. So normally I'd try to put in a land command, as you see here, but there's something still a little bit of a limitation of the software. It won't engage the landing profile. I think it's because there's no actual hardware to kind of initiate that landing sequence. But something I still need to play with. This is only a problem with the fixed wing aircraft. It works just fine with the copter type. But you see, though, I did do the RTL, or return to launch point. So with this command, the drone will go back to its original launch point, or whatever you've specified as its home position. And it'll just loiter in that area. Again, normally if, for a copter, this would also initiate its landing sequence, but for the fixed-wing drone, that's a separate land command, which even though I'm in the vicinity of the launch point, I still can't get that landing mode to initiate. But that's pretty much the demonstration here when we are using the ground control station on the actual box or VM that I'm using to simulate the kinematics through the JSBSim, as well as the actual drone software, the drone operating system, which is ArduPilot. And the ground control station, like I said before, is MAVLink, which is a Python-based control system, which is why it's so much of the command line here. Anyway, I think that's about it. In my next video, I will use the copter, and I will demonstrate how to use a separate VM for the ground control station. So please take a look at that.